Hello and welcome to eBPF and the future of osquery on Linux for osquery at Scale 2021. I know that this is a topic that could sound like pretty low level and tricky to follow, but I just want to say that we're going to be keeping it pretty high level, and so don't be scared off by the terminology. Pretty much anyone who's familiar with Linux, either from a operations perspective or a security perspective, ought to find some value out of this presentation for understanding osquery on Linux. So I'm Zach Wasserman, co-creator of osquery, and I sit on the osquery technical steering committee these days. I'm a co-founder and the CTO of Fleet DM, where we're working to make the whole osquery stack open and accessible. I'd like to give a big shout out to my silent accomplice here, Alessandro Gario. He's a senior software engineer at Trail of Bits, and he contributed invaluable knowledge to this presentation and did a substantial amount of the implementation of the new BPF facilities that we have in osquery. So thank you to Alessandro. So we'll start by looking at Audit, the audit framework in osquery, which is the older method of doing a lot of process auditing on Linux. So these are tables that you are probably familiar with if you've been using osquery on Linux. And these are all powered by the audit framework. We've got things like process events, process file events, socket events, user events, AppArmor events, SE Linux events. And those are all coming through the audit framework. To configure this, you pretty much just need this as a base configuration. Enable the audit subsystem, allow osquery to configure audit, and then allow osquery to attempt to persist itself in the connection to the audit producer. And then there's a number of separate features that are available from audit that we need to turn on independently, depending on what we're interested in osquery. These are AppArmor events, BIM events, fork process events, kill process events, or process events themselves, which would refer to like exec syscalls, SE Linux events, sockets, so like TCP and UDP socket connections, and user events like user logons, logoffs, creation, and that kind of thing. And all of this is to say that Audit can provide a ton of data on Linux systems, and for the most part, it works. It's pretty awesome. Of course, there are some drawbacks to using Audit, and that's the motivation for some of this more recent work. So what are those? Well, there can be only one. So there can be only one consumer of the generated events from Audit. And we've got that Highlander joke coming from Richard Guy Briggs at the Linux Security Summit in 2018. But Audit's design only allows a single consumer of the generated events. And so receiving audit events in osquery means disabling Audit D. And Audit D is typically what folks are using to get those audit logs into like your var log audit.log file. So you disable Audit D, you don't get logs in that file. And there are some tools that expect to be able to retrieve events from that file. So these are tools like SE Alert, which allows you to understand the failures that are coming out of enforcement actions in SE Linux, or tools like Audit to Allow, which would look through that audit log and use that to generate the appropriate allow policies to configure SE Linux to allow the workloads that you want to support. And what we found was that there were users in the osquery community who wanted to be able to run these tools alongside osquery. and they wanted to be able to do that without having to turn off osquery while still maintaining the process and socket auditing capabilities that are in osquery. And so this was a major drawback, that there could be only one listener. And then the other drawback is in relation to containers. And one thing I'd like to point out, I think there's a common misconception that Audit does not work with containers. And Audit does work with containers. It was fixed in this bug referenced here. And you can get the events that take place within containers. Those will absolutely still make it to the Audit framework. But the thing to understand is that Audit is not really aware of containers, like the lower level concepts that make containers work on Linux. We're talking about things like C groups and namespaces. Audit isn't able to use those to correlate the events between various parts of different containers running. So then we have eBPF, and you might have heard of BPF as Berkeley Packet Filter and eBPF as Extended Berkeley Packet Filter. And that extends this concept of filtering packets through small programs in the kernel to really filtering like any sort of data or action that's happening in the kernel and even beyond. So the way that I think about this conceptually is that eBPF allows us to have essentially programmable hooks into all sorts of operations we might be interested in within our operating system. So we can write little programs that we feed into the kernel, and the kernel executes them upon all these different triggers that we might be interested in. So we can measure and track events taking place within processes, in userland processes. We can track syscalls. We can get into the networking stack all the way down to the level of packets. And we can look at file systems, and we can look at the I/O from the processor to any external devices that are connected. So we get a ton of power that we can take advantage of, and this all happens right within the kernel. So we minimize the overhead that is common to writing userland processes to do these kind of things, because they have to communicate across the kernel boundaries, and the context switching involved in that brings a high performance cost. This brings up the question, how can we load code dynamically into the kernel in a safe way? Because we don't want this to be just a vector for having our whole system owned. So for one thing, it requires privileges to be able to load eBPF code into the kernel. Nothing fancy really. Typically, this is just a root, although a root user. Although you can use SE Linux to require specific capability to do this, and it is possible to extend it beyond just the root user, but I don't think that's a typical setup. And then eBPF inside the kernel has a program verifier that can ascertain the safety of running that program within the kernel. So, things that we're concerned about are like, what kind of performance impact might this have? How much data can it generate and process? Could it run forever? Effectively becoming a way to shut down a system, perhaps maliciously, perhaps accidentally. So the program verifier limits the size of the program just in terms of the literal number of instructions. It limits the complexity to what it can safely analyze, and it bounds loops. I believe they even have to be unrolled so that it's very clear that any program that is run within the little BPF virtual machine will terminate. And then the kernel also controls the memory access that takes place from these programs. So you don't just get arbitrary read and write access to kernel memory when you're doing this. So we get some pretty good safety assurances in terms of what we're doing while maintaining quite a bit of flexibility. Now I'll be talking about how we've begun to integrate eBPF into osquery itself. So the current state of things is that we've got the first open source osquery eBPF functionality released in osquery 4.6.0. This is built primarily by Alessandro Gario, who I mentioned above, and I think it's worth noting that it's implemented on top of a library that Alessandro wrote that makes it easier to implement these eBPF programs and make them portable across different versions of the kernel and system configurations. So we've got a really good framework now to expand on that work that has been started. So right now, the tables that are available through the eBPF system are BPF process events, which maps pretty much directly to the process events table that comes from Audit. And then we've got BPF socket events that similarly maps to the socket events table. And I just want to put this ... here to underscore that there's going to be a lot more coming here, because now that we've got the capabilities, we've got the abstraction in there, and we've got the framework for doing this, there's going to be opportunity to start bringing in all sorts of data that osquery users are interested in. To configure eBPF in osquery, you really just have to enable this one flag, which says enable BPF events. Once you do this, osquery will register the eBPF probes with the kernel, and we'll actually have code executing within the kernel, collecting the data that we need. And then we have code in the user part of osquery, which is communicating with that over the mechanisms provided by BPF and bringing that into the event subsystem of osquery. So it's really just this one flag that we need. Of course, you also must be root or have capability to insert BPF programs, although almost everyone's running osquery as root because that's necessary for most of the visibility that we're interested in. Anyway, and there's no need to modify any other processes or any other daemons that are running on the system, including Audit. So this solves that problem where now we can have these SE Linux tools like SE Alert or Audit to allow, and we can also be getting process and socket events within osquery. I'll just point out that there's some flags for tuning the memory usage of this. We won't dig into this too much here, but I'd say if you're working with this in a production environment, you may want to look at configuring these flags, which will modify the memory usage of the BPF subsystem within osquery. And I think that because this is also new, we're working to tune the defaults as well. So I think that we've got a good baseline, but we're going to make sure that what we end up with as a default here is what works for the vast majority of use cases. In terms of compatibility, the BPF functionality in osquery targets kernels 4.18 plus. So that means essentially anything more recent than 2018. And my understanding from Alessandro is that it's possible to extend this compatibility back to 4.10, which would get us back to 2017 kernels, if we're willing to make a couple of sacrifices in terms of the data return. So I think that whether that happens will probably mostly depend on who's using this and what they want to use it for and where they want to use it. And I'll also point out in terms of compatibility, because this is an issue with some tooling that uses eBPF, where if the eBPF programs, the probes are pre-compiled, then they may not match the exact memory layouts and interfaces within the kernel. And so we get around this in Alessandro's library by generating the probes at runtime. And this means that our one osquery binary can insert the BPF probes that will work on most kernels in most configurations. So then coming soon, we've got support for correlating the BPF events with containers. So this is going to be really helpful for addressing that drawback of audit, where we don't know the container context. We can get the information about the C groups and the namespaces that the BPF events are coming from. And soon we'll be able to use that to correlate to the Docker containers that are running on the system, for example. And we're also looking to implement process DNS events table, which is kind of a cool example of how you can start taking advantage of the user space tracing, where you could implement process DNS events by tracing the getAtterInfo function that's used for DNS lookups in libc. So essentially, almost any program compiled to run on a Linux system is going to, at some point, use that getAtterInfo function at the lowest level of how it's dealing with DNS. So this wouldn't cover 100% of possible DNS lookups, but it would be a pretty huge amount of visibility, and it would also come at a relatively light cost, because again, we're able to compile these events within the kernel and then share them back into the user space memory in a way that's much more efficient than we might have been able to do in the past. And so what gets me really excited about all of this is that now we have a pattern to instrument nearly anything on Linux. We can get those system calls, whichever they are, that we're interested in. We can attach to kernel trace points. We can attach to user space function calls. And all of this has potential to be dynamically configured at osquery runtime. And because these programs run within the kernel, we can do more of this kind of instrumentation while making less of a performance impact on the systems. So I think that now is really the time for us to imagine what is the missing visibility that we thought maybe before wasn't possible or wasn't practical. Like, let's start digging into these things. So from a security space, just some high-level ideas. We can instrument any and all syscalls of interest, any of them that we think are relevant for our security use cases. We can track the signals being sent to processes. We can track kernel modules being loaded and unloaded, and we can track things like LD preload, which is a possible way to override which functions are being executed when externally linked functions are called in a binary. So this is like one of the persistence techniques for Linux that you'd find on the MITRE ATT&CK framework. From a DevOps and SRE perspective, again, we can instrument any and all syscalls of interest. So all of a sudden, this may open up, by deploying the osquery agent, we can get not only the security wins, but we can get the operations wins to understand what's going on in those systems. But I think that we can see a lot of examples out there right now of using BPF to measure all sorts of data points of interest, such as the latency and the resource consumption of the network stack, our file system, or any kind of I/O within the system. We can count and measure the functions within user space programs So we can start dynamically instrumenting something like, imagine if we want to hook into the functions from our MySQL server and start instrumenting those. And this could start to help track down bugs in production and performance wins for the whole organization. So my invitation to everyone is, let's look at the tools of today, the eBPF tools of today. There's some great stuff out there like BPF Trace, BCC, that have nice ways to start taking advantage of the capabilities of BPF. And I think these are fertile grounds for finding the use cases that we might bring into osquery. So I encourage you all to go out and look at these projects, look at the data that they're collecting, and think about what of this would map well to the SQL model in osquery, or how can osquery just be useful for aggregating and shipping that information from the hosts into our logging pipelines, or maybe making it available via live query. We've built these amazing abstractions, and I think it's really cool to think how the new data might be enhanced by the abstractions that we've built in osquery. And to conclude, I'll just reiterate a couple of points here. So Audit and eBPF are both viable approaches for doing this kind of low-level instrumentation on Linux. And I think that users need to consider some various points when deciding which to use. And some of these would be like the support that your kernel has, the workloads that you're running on your system. And it could be reasonable that a mix of the two approaches is what you use within your organization, because you have a wide range of kernels deployed and you have a wide range of workloads. And in some places, you'll use one, and some places the other. And the last conclusion is that eBPF has potential to dramatically increase the scope of observability with osquery. So we're in the really early days here. We know it works. We know it can be done. We know it can start replacing some of the functionality that's there, but there's a whole world of more that we can do with this information. So being closer to the kernel, running these programs within the kernel, means we can record more data with a lower performance cost. So we can take advantage of that to get at things that we never thought were possible before. So let's, as a community, continue to imagine the best use cases, and let's get involved, write code, or work with folks like Trail of Bits and Alessandro to make these things happen. Thank you for listening today. You can feel free to reach out to me at Slack on Slack at ZWAS, on Twitter, the Zach W, or zach@fleetdm.com. And I'd love to chat if you'd like to work together to deploy a fully open osquery stack, or just want to kick around any of these ideas. So thanks for coming.